My name is Dhanjot Singh, and this is my demonstration for the Event-Driven Computing Assignment 3, the GPS tracker GUI build using Java Swing and Sodium FRP. In this video, I will demonstrate all major GUI features, I'll explain the test cases, and walk through the key parts of my implementation. To start with this, you can see my GPS GUI Java class, or you can see the structure. For the structure of my code, I'll show you the readme.md file. It has the major Java files like GPS device, GPS service, GPS events, example, and readme file, which I've and also in my library I've kept the charts. To start, I'll compile and run the GUI. For compilation, I'll first compile all the files we can see in the compilation code. I've combinedly compiled GPS service.java, GPS event, GPS GUI, and example.java. The files have been compiled. Now I'll run the GPS GUI. You can see a sample of the UI of the tracker, which has a latitude, longitude, and it has 10 trackers from T1 to T10, and all the trackers distance over last 5 minutes, and it has the distance which will be increasing. The interface updates automatically with live GPS events streamed from the service. You can see the tracker positions in updating real time. The last event field shows the latest incoming event is in CSV format, ID, latitude, longitude, altitude, and it also auto clears after 3 seconds to avoid clutter. Each tracker shows simplified data. We intentionally hide altitude in tracker table as per the specification. To show the range and filtering, first I'll demonstrate the range features. I will enter a sample latitude and longitude. Note that south latitudes and west longitudes are negative. The wide range is -90 to 90 for latitude and -180 to 80 for 180 to 180 for longitude. First, I'll keep it out of range. I'll keep the latitude more than 90. I'll keep it in the range. It says latitude must be between -90 and 90. Same if I'll do the same thing for the longitude. It will not allow the longitude or tracker to run. It's not in the range. Now for a sampler, I'll keep both of them in the range. After clicking set range, the range label updates and the combined output below now displays only trackers with that rectangular area. You can see the combined output becomes empty after filling the filter logical works correctly. Now you can see the distance increasing. We will keep it for some time because the T4 tracker takes time to connect. Before that, I can say that each tracker also maintains a rolling distance count over the last 5 minutes. You can see these values changing as trackers moves. This helps monitor short-term movement efficiently as required by the assignment. Coming to the code explanation, I'll show you the GPS GUI code. Now let's look briefly at the implementation. The GUI uses the Sodium FRP library where I define streams of GPS events and cell sync range. Object to track the current rectangular range dynamically. There is a stream GPS events in which like the objects are mapped and filled for per tracker and combined views. The reflection-based wiring methods ensure compatibility even if the instructor's API changes. For example, when the code tries to call stream per tracker or stream more automatically, if not found, it will fall back to the manual filtering. I can show you the GPS GUI public class, the build UI, and I have also included the try calls stream per tracker, the snapshot which checks the current range, the JP panel, port label, and wire UI to FRP. These are the basic class. One, I have kept the attached streams, which has the per tracker raw, and it has hash mapped the entire thing. Finally, I'll come to my test class. This is the test file in which I have given 22 tests. Few major tests that commonly I gave would be the negative coordinates and with the zero coordinates. I'll run the test here. I'll open my terminal. This is my test code. I'll run the test. This is the GPS test file for file being compiled and executed using JUnit. As you can see, all test cases, initialize, ranged, and test event timing passed successfully. This validates that both event handling and GUI updates work as intended. I gave 22 tests and all of them passed. Now if I come to the file that we opened, we can still see the trackers moving, the distance increasing. You can see the 10 tracker simplified display, which is the ID, latitude and longitude. It's changing for T4. It's going to take a minute. All of it has been mentioned in the README file. I've used the run.sh. Each tracker also maintains a rolling distance. As I said, it counts over the last 5 minutes. We can see the values changing as trackers moves. This basically helps to monitor the short-term movement efficiently as required by the assignment, and also it's help for an efficient range. Now we can see all the distance moving except for the T4. The T4 takes a bit time to connect, approximately for 5 minutes. Yeah, you can see the T4 also changes. The distance increases for all the trackers from T1 to T10. To conclude, this GPS GUI demonstrated efficient event-driven programming using Sodium FRP. We have showcased the live tracking, dynamic range filtering, auto clearing, event displays, and successful test cases. The video link is provided in my testing PDF also, and the implementation fully meets all the assignment requirements. Thank you so much for watching.